Hello, hi everyone. Welcome back to the yet another video in the series where we are learning about tree algorithms and we're solving problems on trees. So far we have learned about depth first search and breadth first search, and we have solved a couple of problems on that. So I hope you are learning something new. I hope you are learning how to apply these algorithms to various problems. So let's solve one more problem today. So the problem is tree distance is 1. So in this problem you're given a tree consisting of n nodes, and the task is to determine for each node the maximum distance to another node. That is, again we are given a tree. Let's take this tree. We have tree with 5 nodes, and what I want to do is I want to find the distance, the maximum distance node for every node. Like for node number 1, find the node which lies at the highest distance. The node is 5, also 4. And what is that maximum distance? It is 2, because we have 2 edges from 1 to 4 and 2 edges from 1 to 5. So the answer for node number 1 would be 2. Okay, the maximum distance which we can get for node number 1. What will be the maximum distance for node number 2? What is the node which is at a maximum distance from this node? Obviously that will be again node number 4 and node number 5. And the distance would be 3, because we are adding one more edge. So the answer for node number 2 will be 3. Same goes for node number 3. What is the maximum distance for node number 3? It would be 2. And the node which is at the highest distance will be this node, which is node number 2. So for node number 3, the answer is 2. What will be the answer for node number 4? It would be 3, because the node at the maximum distance will be this, node number 2. So we'll have 3 here. And we'll have 3 for node number 5 as well. Okay, so the array will be like 2, 3, 2, 3, 3. Okay, these are the maximum distances which I can get for any node of the tree. And we have 5 nodes in this tree. So let's solve this problem. Let's see how we can solve this problem. So if you haven't watched the previous video of the series, then make sure to watch that video where I explained how we can find the diameter of a tree. So let's reiterate over the definition. What is the diameter of a tree? The diameter of a tree is basically the distance between 2 nodes which lies at the maximum distance from each other. Like here in this tree, the diameter nodes will be node number 2 and node number 5, because they lie at the maximum distance, which is a distance of 3. The node number 2 and 4 also can also be like the path between them also represents a diameter, because the distance between them is again 3, which is the maximum distance between any pair of nodes of the tree, and that's called the diameter of the tree. So the diameter for this tree is 3, and the diameter nodes will be like 2 and 4. Okay, so we know how to calculate these nodes, how to find these diameter nodes, and how to find the diameter itself. If you don't know how to do this, please make sure to watch the previous video in the series. Then you can continue right from here. So how the definition of a diameter will help us to solve this problem. So notice that what I want to do is I want to find the maximum distance for every node of the tree. The maximum distance for node number 3, the maximum distance for node number 1, the maximum distance for node number 4, 5, and so on. So how we can do that? The maximum distance is simply the distance to the node which lies at the highest distance, right? Simple. And that node, for any node of the tree, has to be one of these diameter nodes. It is obvious, because there is no other node which lies at a greater distance than these 2 nodes. Like for any node, take node number 3. Find the node which lies at the highest distance. That will be node number 2. Okay, this one. Because you can see this is one of the endpoints of the diameter, and for the diameter of the tree, by definition, we have the maximum distance between these two nodes. Okay, we have the maximum distance between these two nodes of the diameter. So from node number 3, the maximum distance node is this node number 2, and this node is one of the endpoints of the diameter, this one, right? And the distance is 2, which is the answer. Let's take node number 1. My claim is the maximum distance node has to be one of these 2 and 4 and 2 and 5, because 2, 4, 5, all of these are diameter nodes. So you can see that the distance from 1 to 2 is 1, while the distance from 1 to 4 is 2, and that's the maximum distance, and hence this, and we can also observe that 4 is one of the diameter nodes. Okay, so same goes for node number 2 as well. The maximum distance node is the other end of the diameter, which is node number 4, and the maximum distance is 3. Same goes for 4. The maximum distance is the other end node of the diameter, which is node number 2, and the maximum distance is 3. Same goes for node number 5. The maximum distance node has to be one of 2 and 4, and it is 2, because it lies at a distance of 3 edges from node number 5. So I hope you got the idea what we want to do. So the strategy is simple. Find the diameter nodes. There will be 2 nodes, and now for every node of the tree, just find the distances from both of these nodes to all other nodes of the tree. Like here, take node number 2 as the source node. Find the distance to all other nodes. So let's find the distance from node number 2 to node number 1. It will be 1. Distance from node number 2 to node number 2, it will be 0. Distance from node number 2 to node number 3, it would be 2. Distance from node number 2 to node number 4, it would be 3. Distance from node number 2 to node number 5, it would be 3. Let's find the distance from node number 4 to all other nodes. It would be, let's find the distance to node number 1. It would be 2. Find the distance to node number 2. It would be 3. Find the distance to node number 3. It would be 1. Find the distance to node number 4. It would be 0. Distance to node number 5. It would be 2. Fine, right? Okay, so we have these 2 arrays prepared. Now what will be the answer? The answer will simply be, like, for node number 1, what I claimed is the maximum distance node for every node has to be one of these nodes. So if the distance from node number 2 to 1 is 1, then the distance from 1 to 2 will also be 1. If the distance from 1 to 4 is 2, then the distance from 4 to 1 will also be 2. Okay, so what will be the answer for node number 1? It will be the maximum of these 2 values. That is what I am saying, that either the maximum distance node is 2 or it is 4. So we have to take max of these 2 values, which is 2. Same goes for this one. Take max of these 2 values, which will be 3. Same goes for this. The max of these 2 values, which will be 2. Same goes for this. The max of these 2 values will be 3. Same goes for this. The max of these 2 values will be 3. So this is my answer array. Okay. 2, 3, 2, 3, 3. Fine. So how we can implement this strategy to solve this problem? How we can find the distance to all other nodes of the tree starting from one of these nodes, like the distance from node number 2 to all other nodes, the distance from node number 4 to all other nodes. How we can do that? That can be done using depth first search strategy. So let's discuss that. Like, we can do it using DFS, we can also do it using BFS, the choice is yours. Here in this video lecture, I will solve this problem using depth first search strategy, and doing it using BFS is an exercise. So let's draw the tree again, and let's dry run the approach. So this is my tree. Node number 1 is connected with node number 2. Node number 1 is connected with node number 3. 3 is connected with 4. 4 is connected with 5 with a direct edge. Okay, so let's start. So we'll use DFS. We'll start First of all, the very first step is find the diameter nodes. Find the diameter nodes. That will have like node number 2 and node number 4 as the diameter nodes. Now use DFS to find the distance to all other nodes, taking both of these nodes as the source node. Okay, so find distances to all other nodes from 2 and 4, taking these nodes as the source nodes. So let's do that. So we have found the diameter nodes, which are node number 2 and node number 5. So let's run the DFS from node number 2. So node number 2 is the source node. And since I want to store the distances, I will use an array like this. An array with 2 rows. The first row is dedicated to the single source distances for node number 2, the first end of the diameter, and the second row is dedicated to the second node, which is node number 4. That is, I want to find the distances from node number 4 to all of the nodes, and I will create this type of an array, and let's write 1 2 3 4, and then we'll have 5. Okay, so let's solve this. Okay, so what I was doing, let's start the DFS. Okay, let's start the DFS from node number 2, and let's pass one more variable, which is the depth of the node. So the depth of node number 2 is 0. Okay, now so for node number 2, store 0 here. Okay, store 0 because node number 2 lies at a distance of 0. Now recursively call the same function for node number 1. So DFS node number 1, and the depth for node number 1 increases by 1. It becomes 1. So for node number 1, the depth will be 1. Again call the DFS for the so this is visited, and now let's visit this, which is node number 3. So DFS, the depth of node number 3 would be 2. So 3, its depth would be 2. So for node number 3, assign 2. Now again, we'll call the function recursively for node number 4. So DFS 4, and its depth will be 3. So store 3 for node number 4. Now node number 4 do not have any child, so move back to node number 3, and this call is removed from the call stack. Now from node number 3, visit the other child, which is node number 5. So DFS 5, and pass in the depth, which is 3. So for node number 5, assign 3. So in this fashion, the distance array for node number 2 is prepared, right? Now same goes for node number 4. Let's prepare the distance array for node number 4. Now from here, I will move back to node number 3, then move back to node number 1, then move back to node number 2. So I will remove these function calls one by one. Okay, now let's start the DFS from node number 4. So for node number 4, the depth is 0. Move to the adjacent node, the child node, which is node number 3, the depth becomes 1. Now move to node number 5, the depth is 1, the depth is 2, and also for node number 1, the depth is 2. For node number 1, the depth is 2, and for node number 2, the depth becomes 3. So in this fashion, I will have my arrays prepared for both of the nodes, for node number 2 as the source node and for node number 4 as the source node, right? And now after that, what I can do is, Okay, let's implement it. The answer will be simple. The answer is nothing but I will iterate over all of the nodes starting from 1 to 5, and for every node print the maximum of these two values. So print max of these two, which is 2, then print max of 0 and 3, which is 3, then print max of 2 and 1, which is 2, then print max of 0 and 3, which is 3, then print max of 3 and 2, which is 3. 2 3 2 3 3, like this. This will be my answer for this problem. So let's just jump to the code implementation part. Okay, the very first thing is to prepare the given tree, then call the BFS to find the basically the endpoint, like the first endpoint, the endpoint of the endpoint of the diameter. So this P will have the first endpoint of the diameter, then find the second endpoint of the diameter. So we know how to do this. We have learned this in the previous video. The actual job of this problem starts right from here. So I declare an array, DP array, this array which I explained here, of dimensions. The dimensions are, okay, n plus 1 into 2. So I'm taking 2 columns and like n plus 1 rows rather than taking 2 rows and n plus 1 columns. That's okay. Now I call this DFS function from this first source node, which is the first endpoint of this diameter. So in this pair, the very first element will be this p dot first, which is the first end of the diameter, and I'm passing these arguments, which is the first argument is the parent. So since this is the source node, it do not have any parent, so I pass 0. Then I'm passing the depth of this node. Since I'm starting from this node, this is the source node, the depth will be 0. Then I'm passing this variable, which will be used to point to the index of the column. So I'm passing this 0 because I want to store the results for this source node in the very first column of the matrix. Then I will pass this tree, then I will pass this TP array. So let's see how this function works. Okay, so here we have a parent, the current node on which we are standing, the depth of this current node, and the column. C is for column in which I want to store. So for the very first end of the diameter, this will be 0. For the second end of the diameter, it will be 1. And this is the tree, and this is the DP array. So let's store the value for this TP, and then iterate over the child node. So if I find a unvisited child, or we do not have visited array, if the child is not the parent, then in that case recursively call this DFS function for this child, and then okay, this node becomes the parent, and then this child becomes the current node, and then this t plus 1 becomes the depth, becomes the new depth for the child, and then pass C as it is, and then pass this adjacency list and pass the DP as well. Okay, so that's how we use this. That's how we calculate the distances to each to all other nodes starting from a source node. So this was for the very first end of the diameter. Then I do the same for the second end of the diameter. Call the function again from the taking the second node as the source node, right? Then calculate the max of these two values, like I did here. Max of this value and this value, max of this value and this value, this value and this value for every node of the tree, and that's I'm doing here. So that's all we have to do. Let's just run this code over an input. So let's take this input of the problem tree distances from the CSES problem set, and let's see if it works. Okay, this is a 2D array, I'm sorry, for this node, for the column as well. Okay, I want to store it for for two nodes, right? So that's why there was a mistake. Okay, so we get 2 3 2 3 3, which is the answer indeed 2 3 2 3 3. So let's try to submit it. Okay, it got accepted, and I hope you learned something new from this problem and you enjoyed watching this video. And you can also solve this problem using BFS, so that you will do as an exercise. And that's all for this video. If you like the video, then hit the like button and make sure to subscribe to the channel. And I will see you in my next video.